So next to present is Clayton Peterson from the Université de Montréal, speaking on action logic and compact closed categories.
Thanks. So what I'm presenting today is part of a bigger project, actually. It's part of my PhD thesis. And it is to be applied in the context of the project, but I won't be talking about the project. So the plan of the presentation, my main concern is to introduce the logic able to model human actions and not to model programs as in dynamics objects. So first I'll be talking about my foundational framework, which is category theory and deductive system. It is inspired by the work of Jim Lambek. Then I'll speak about the action connectives I want to consider for human actions and the logical properties of these connectives and of the deductive systems. And then I'll present the action logic and the propositional action logic. The difference between the two is that in the latter, there are declarative statements, but not in the former. And then I'll conclude with remarks for future research. So I assume that you guys are not that familiar with category theory, right? You're familiar? Okay. So briefly, I won't be giving every categorical definition, but the basic definition of a category is that you have a collection of objects and a collection of arrows between objects, and you have composition of arrow defined, meaning that, well, if you have some arrow between phi and psi and another between psi and rho, then you have the composite arrow, GF. And this composition is associative, meaning that this here is a commutative diagrams. And you also have identity arrows between objects which respect the identity laws, which means that basically this thing here commutes. So when we're thinking about logic, we can consider deductive system as a collection of formulas, and we can consider with the formulas are objects, and the arrows are equivalence classes of proof between these formulas. So we can define a deductive system as this kind of collection satisfying the identity axiom and the cut rule, and we can show that this satisfies the definition of a theory. So basically you can define a deductive system as some category where we satisfy these two axioms. Now, the interest of, can you guys see the two axioms on the bottom of the slide? Barely, okay, we'll talk about it. So the interest of this approach is that we can see clearly the relation between the properties of the logical connective and the categorical structure of the deductive system. And we can see that the logical connectives appear in a specific order, so that's kind of interesting. We can add to a deductive system a tensor product, which in logic would be a conjunction. And this gives the definition of a monoidal deductive system, which is a deductive system satisfying also the rule for increasing monotony here, the rule for associativity of tensor product, and note that if we have two lines, it means that the rules can be applied upwards and downwards. And here we have two rules making one here into the unit of tensor product. Then we can introduce a conditional or an adjoint to the tensor product by a rule for closeness. So a monoidal closed deductive system is a monoidal deductive system which satisfies either one of these rules or the two. Because it can satisfy either one of them when the tensor product is not commutative, but if it is, then one rule will depend on the other, and so we'll have both satisfied. So this makes these guys here into the adjoint to the tensor product. So note that if the two rules are satisfied, then this here can be derived from these two rules and other rules. Negation is, as usual, defined by with a special object 0. By not phi is phi implies 0. Now, a symmetric deductive system will be a deductive system satisfying this braiding rule here, which makes the tensor product commutative. And if it is symmetric, then we can prove L from R and vice versa, and CL prime from CL and vice versa. Then we can introduce classical negations by these two axiom heirs. So monoidal deductive system with classical negation will be a monoidal closed deductive system satisfying these two things. And if the deductive system is symmetric, then we can prove one negation from the other. And finally, and if you don't see do you see axiom down? Oh, okay, I'll just. Oh, okay. So the compact deductive system will satisfy is a symmetric deductive system satisfying these two axioms here, which makes actually phi implies psi logically equivalent to not phi and psi. So if you think of it in terms of propositional logic, this is quite weird, actually. So this would it would need to be a disjunction here rather than a conjunction. And if we have a compact deductive system, then we have classical negation can be derived from the axioms. Finally, a Cartesian deductive system will be deductive system satisfying this axiom here, making one into a terminal object, and this rule here making the tensor product into a categorical product. And from these guys, we can prove the other rules of a monoidal deductive system. So the interest of this kind of approach is that, well, we can show that these deductive systems are instances of specific categories. So it allows us to classify different systems of logic through their categorical structure. And so we have here the inclusion between the deductive systems. So we have the monoidal, closed with classical negation, then the symmetric, the Cartesian. And from the symmetric closed with classical negation, we can either go compact or Cartesian closed. Now, the properties of the cotensor can be analyzed within the opposite category, which is basically the same, the category which shares the same objects, but where the arrows are reversed, and where you replace the tensor by the cotensor and one by 0. So you have the coversions of the rules to have co-deductive systems. Look, the two main action logics in philosophy, which are state logics and dynamic logics based on Boolean algebras, it can be shown to be instances of Cartesian closed deductive system with classical negation. Actually, I should have said that earlier. There are representative for these class of deductive system. So here we have classical logic, here we have intuitionistic logic, here we have multiplicative linear logic, here we have intuitionistic multiplicative linear logic, and so on. So here, Boolean algebras and state logic can be shown to be instances of Cartesian closed deductive system with classical negation. And there are also dynamic logic based on clean algebras, which, if we do not consider the clean star for the iteration, can be defined as monoidal and co-Cartesian deductive system with sequence and choice. So now the logical connectives I want to consider. First, I note that the properties of the logical connectives can be correlated to type of deductive systems we're using. So in every deductive system, we'll have a tensor product associative. Commutativity of the tensor comes when it's at least symmetric, and the idempotence of the tensor product comes when it's Cartesian. So idempotence basically means that phi is logically equivalent to phi and phi. So the primitive logical connectives I want to consider for human actions are, well, action conjunction first, which is simultaneous action conjunction, and is read phi together with psi, and action sequence phi and their psi. So I won't be considering iteration of human actions because I think they can simply be represented by finite sequences, so they're not primitive. And I won't be considering choice as an action because, well, I don't think that choice in itself is an action per se. I mean, we can have a choice between actions and we can choose, and choosing will be an action, but the choice will be expressed in the propositional action logic with declarative sentences. So if we look at the connectives and the action logic in the philosophy literature, we see that, well, sequence is correctly axiomatized in dynamic logic based on clean algebras, but conjunction of action satisfies idempotence in dynamic logic based on Boolean algebras and in state logic. And I don't want to have idempotence of action conjunction, well, simply because it is false that action conjunction is idempotent. So for instance, and this is, I think, similar to Girard's example when he introduced linear logic, if I give $1 to someone, this is not logically equivalent to giving $1 and giving $1. So I don't want that property to be satisfied. So we saw that the property arises in a Cartesian deductive system, and so the obvious solution is just to go into a weaker structure in symmetric deductive systems. So I now turn to the action logic and the propositional action logic. So as in dynamic logic, there's a distinction between actions and propositions, declarative sentences. I distinguish between an action logic for the logic of actions and a logic to talk about action, which will be propositional action logic. So first, the language of the action logic. So we have a collection act of atomic actions. We have a bullet here, which is the action conjunction, and alpha and beta is read alpha together with beta. We have the O minus here, which is the adjoint to conjunction, and which is something new, actually, as an operator. This is read alpha without beta, so we can have actions together, and we can have actions without other actions. And there is sequence, alpha, and then beta, and the star is here, which is the unit of both sequence and conjunction. So just to give some philosophical assumptions I have to understand better what I mean by action negation, which I'll introduce in 2 minutes. As in criminal law, there's a distinction between action and intention. I do not assume that actions or negative actions are intentional. So acting does not mean acting voluntarily necessarily. You can, but it's not. You can do things without meaning to do these things. So I just assume that an action is something that has repercussions in the world. So neither actions or negative actions need to be intentional. So the action negation is defined usually within the framework of deductive systems by not alpha is, by definition, the no change without alpha. So basically the idea is to say, well, consider this no change action which is also, by the way, something which is impossible to perform if we assume that every action has some repercussion in the world, then the no change action cannot actually be performed. So either an action or its negation will have some repercussion. So you take this no change action, you subtract alpha, and you get the negation of alpha, basically. And there's an interesting remark here, which is the isomorphism between these two formulas here. So in the natural language, the example we can give is, so we have, if we have not alpha and beta, it's the same thing as beta without alpha. So if I go to work without wearing a tie, it's the same thing as going to work while and not wearing a tie. So we have this logical equivalence, which makes our action logic defined as a compact closed deductive system. And I should actually have said that earlier, but I'll say it right now. No, I think it's it. So the compact closed deductive systems are instances of compact closed categories, which is in the title of the paper, so I just wanted you to know where I'm going with this. So the action logic is defined by sequences axiomatized by a monoidal deductive system, as in dynamic logic based on clean algebras, and the other fragment with action conjunction and the without connective is defined by a symmetric closed deductive system satisfying these rules here, making it into a compact deductive system. So just a little remark. Here I change the order of the notation here. If we refer to the rule earlier, it would be alpha, the connective, and then gamma, but I wanted to keep the intuitive meaning of the without connective, so I just reversed the rule. And so we have action conjunction defined here and action sequence defined here. Now, regarding the propositional action logic, I assume that action propositions are true only when we have proof that the action were done. And so a consequence of this assumption is that the propositional action negation will have an intuitionistic here. So basically, basically the propositional action logic is defined as intuitionistic logic satisfying some special rule here. So consider a collection AP of action proposition, which is defined by this condition here. So if you have an action which is well formed in the action logic, you have the bold notation of this action, an action proposition in the propositional action logic. So the basic idea is to map each action to a declarative sentence in the propositional action logic. And we have a rule here, implying that if we have an arrow between two actions in the action logic, then we also have this arrow between the declarative sentences referring to these actions. And so it's defined as a Cartesian closed deductive system. So I could have had only this rule, but I wanted to impose some more structure on this thing. So I actually define the rule psi here as a vibration. I'll explain in 2 minutes what a vibration is. So to do so, I need to augment this action logic with a dummy class, an equivalence class of dummy actions, which I call delta here, and it satisfies this action here. So the basic idea is to sit like the compact closed structure onto a dummy initial object in order to define a vibration between this thing here and the propositional atomic fragment of propositional action logic. So the pal star is here is the atomic fragment of the propositional action logic, but without truth. So we only have atomic propositions and false. And the rule psi is defined such that, well, psi of star is false, psi of delta is false, and psi of alpha is bool alpha, and is defined as a vibration. So a vibration, basically what it means is that when you have this situation, then there's always an arrow which is Cartesian over this arrow here. So what Cartesian over means is that we have an arrow F which is mapped to this arrow here. And whenever we have another arrow G such that it is mapped to the composition of U and W, then we have one and only one arrow here. So don't be scared, I won't. I know this is a lot of arrows, but just to explain why I did this. So the delta constant is used to deal with the fact that this is initial in the proportional action logic. Otherwise, we would have used the star and it would have made it into an initial object. I didn't want that. Now, the interest of this definition is that whenever we have an arrow from alpha to the no change action, it implies that it's actually isomorphic to it. So if an action implies no change, then this action in itself is no change. And the other, and well, the big interest of this definition is to basically have this situation. So whenever we have arrows in either one or the other of these logic, we have the same arrows in the other. So the two structures behave together. Just and finally, just some commentator of the paper suggested that we couldn't be able to model context in the worlds and conditions for action. So if we want, we can just augment this thing with a collection of descriptive atomic atomic propositions, and so augment the logic to be able to model conditions and facts in the world. So to conclude, the avenues for future / research are to develop a semantics within the algebraic framework of partially ordered residuated monics. I know this is a big name, but it means something. And it's currently done in some other papers. And the basic idea is that as we can show that the deductive systems are instances of specific categories, we can show that some algebraic structures are instances of the same categories. So it becomes easy to construct a mapping between these two and interpretation. Similarly, there's a strong connection between the language of category theory and string diagrams. So it's really easy to construct a string diagrammatic semantics to these deductive systems. So one project will be to define this kind of semantics for the action logic, and the more larger project is to apply this in the context of deontic logic to have actions within the scope of deontic operators. So this is pretty much everything. So thanks for listening, and if there are any questions, I'll be happy to reply.
Okay, so next up we will have two commentaries by the same, but first, Roberto Cuny was not able to be here. However, he did write a commentary for this, which I will now read to you in his absence. So, he says, first a shorter overview of the paper. It proposes a framework for the formal modeling of actions that is based on a category. More precisely, the framework consists of an action logic that is based on a compact closed category and a propositional action logic that is based on a Cartesian closed category. This framework is claimed to have advantages over the two classical frameworks of dynamic logic and state logic. The paper is mainly devoted to justify this claim and to provide a formal presentation of the resulting framework. Issues concerning the formal properties of the latter are not raised. So, his comments. The paper's main move is the passage from the classical frameworks to the new framework. The main justification of the move is a supposed inadequacy of the classical frameworks, particularly of dynamic logic, in fitting some conceptual desiderata, namely a proper definition of actions. Now my question is, or Roberto's question is the justification solid enough to be successful or at least convincing? He has two contrary or reasons to the contrary. On page 12, the last paragraph of that, he says action choice, i.e. the action disjunction, from dynamic logic, it is argued, is no action at all. Hence, we shouldn't include it in our foundations of formal settings for human agency. Fine, but one could say that the same criticism applies to action conjunction, doing something together with doing something else, or performing two actions. That Peterson assumes is a proper action to be retained in his formal framework. For example, take the actions of writing some lines and whistling. It depends on your ontological, on your quote-unquote ontological tolerance, whether writing some lines and whistling is an action. A severe ontological view could say that this is not an action, just two actions performed together. In a nutshell, one could suggest that the performance of two actions is not an action, exactly like choice. This jeopardizes Peterson's account as much as it jeopardizes dynamic logic. The former wouldn't then have a real point over the latter. The second contrary point is on comes from page 14. Action negation is defended as a proper action connector. Is the defense successful? The argument from the law is easily objected to. The argument implies that an action proposition, John stabs Mark, is true if and only if it can be proved true, and that this follows from the evidentiary nature of the law. Roberto has a reply to this. If one commits a crime, then he satisfies eo ipso the necessary and sufficient conditions to be guilty or responsible for that crime. The evidential feature highlighted by Peterson has nothing to do with this. It has to be with the necessary and sufficient conditions to be proved responsible. One must interpret legal procedure in evidential terms, maybe via an intuitionistic logic. But this does not imply that one should interpret law in an anti-realist way. Besides, action negation suffers per se from a number of problems that have been brought to the fore explicitly in Peterson 2004 from the Journal of Applied Logic. And those arguments should be discussed. Retaining action negation does not seem a justified move in this case. The success in justifying the basic conceptual choices is obviously the influence on the technical part of the paper. The latter may well be in perfect order, but until a solid conceptual foundation, conceptual justification is presented, the technical part loses its appeal. So, don't respond to that.
You want to respond to everything?
Well, if you want to make some comments about
no,
I'll stand over here. You can pretend I'm
But we can have the other commentator.
Okay.
Yeah. Will you be able to send me this?
Sure.
For the references.
Sure.
So I also wanted to, so I should start actually, because the other guy said another thing I wanted to say, but of course, central to the conceptual foundations of your paper is your general aim to have a logical action that And as we mentioned in the previous commentary, what you proceed for doing that is that you first look at state and dynamic logic and say, well, look, there are action connectives, and when we look at that from the perspective of deductive systems, we obtain this Cartesian force category, but this is not what you want, so you want a different class of action connectives, and you want that could be used to model human actions. So basically you to reject, as I said, action connectives from dynamic logic, so in particular you want to keep the sequence, but you want to reject the choice and iteration. In addition, what you'd like to give, so you give arguments for that, so you say, okay, the class of action connectives I want are action conjunction, action sequence, and action negation that you discussed before in your talk. Right? So the way you argument for that is, as has been said, so you said, okay, these are arguments against using this action connectives and arguments for these action connectives. And of course, the problem is that as soon as you get into that, then you'll have people saying, well, look, you can get a claim with counter arguments. But even if you are going for your general aim, which is to have a large number of actions at a very general level for human actions, this type of argument is not yet what you would like to have. You would like to have even something more stronger. You would like to have a principal way to get the connectives. So you have to find a philosophical foundation that tell you, well, these are exactly the action connectives I want, and there is no other action connectives I want to do the list, but you need to get the exact practice. So I was wondering whether you had some idea on how you could provide some philosophical foundation for that. So maybe from the philosophy of actions, you might get a framework that can tell you well, that exactly the action connectives according to this philosophical perspective on what human actions are.
Yeah, I realized that it's quite a difficulty for me because I didn't want to go into metaphysics stuff. And so I didn't, and finally I have ontological objections. So I'll have to dig into this stuff and see in the literature what have been said. So, well, I'll take this objection into account. I didn't thought actually that you could object the same arguments to action conjunction. So, yeah, I'll have to think about that.
But maybe another way you can be more interesting, because this is I think this could be a very difficult approach to get this way of saying, well, this is exactly the property of human action. Maybe the best way you'd like to, you could frame it is that since you have using category theory, and that's usually thought as a very powerful tool for abstractions and dealing with lots of things in a uniform way. Maybe the best way to present it is, well, we can have a uniform framework to deal with lots of types of actions, and that if you fill it with this type of action connected, then you get this result. If you use this type of action connected, you have this result. So maybe you could put, so in this sense, you don't have to commit to any properties of human actions. The only thing you have to show is that your framework is sufficiently powerful that you have to model different type of actions and then represent different action connectives. So I think maybe this is an easy road for the conceptual foundations.
Yeah, it's a good idea.
To go with that physics in this way.
Yeah.
So yeah, so okay, I could have gone into this action conjunction. Though yeah, maybe there is a reason again from this perspective. So do you think if you really think that this is the logic of human actions, and then you have actions that, for instance, does not satisfy conjunction, action conjunction, since for example the type of arguments. So do you think that this should not be considered as actions, or what should we thought about that?
No, I think it's actually a complex action. So even though there isn't any link between whistling and writing, you can do both at the same time. And it's, in my view, it's a conjunctive action of simultaneous conjunction of these two actions. And it forms some complex action. But whether or not it's an action in the ontological sense, well, on this point I don't know. But
because you can imagine this very simple example. For instance, if your action is whether you go upward or backward or left or right, but if you're on the grid, you have a robot and you can only move on the matrix, then you will never be able to do both. Right? You have to have only these four positions. So then you will never have any action conjunction in this case. So
you will have one, but it will be logically equivalent to the impossible action.
All right. Okay. So then that means that you are some. So that means that you would like to kill the properties you put for the action in general, like saying, oh, look, you can just forget about it and continue the logic without it. Somehow it will amount to that if you just put it to contradiction.
But just in the case of impossible actions, because I mean, you can go forward and go backward at the same time. So the conjunction of these two is simultaneously impossible.
Right. No, I understand how you would model it, but again, with respect to the general claim of having resolved human actions, but if you model it in this way, it will amount to say, well, look, in this case, action conjunction is not a properties of these types of actions. So then this means that it's not a properties of actions in general.
Okay, because you can do them together. Okay, I see your point.
But this is it. So the last one thing that you would like to talk to me, that's so can you put again your action logic connectors?
This one? No.
Again, when you have the
This?
Again.
Oh, this one.
Again, before when you have your this one. So I was just wondering, maybe this looks like maybe you could just feed that into dynamic logic. So this looks like a new algebra of actions.
Yeah,
you
that's one project. Actually.
Right. Okay. Because if you take this algebra, you would just have I guess you would just have another dynamic logic with another deductive system, and this deductive system might be the one you would like to write. So this is a way maybe to give a semantics to your syntactic approach. Right? So you can give a direct semantics for that. That will generate a deductive system that you're presenting the R and PAL from a semantic point of view. So this syntactic approach you had here, that could be a semantic way to.
Yeah, sure. Thanks.
Those general questions. So what if someone is working on action logic and deontic logic, so what do you think is the main argument for using category theory? If you have to convince someone, say, okay, you should do category theory.
Why should we do category theory?
No. In this particular context, in the particular context of action logic. So.
Okay, well, in the case of my thesis, it's actually more understandable because I'm working with 5 different deductive systems in 5 different categorical structure. So the framework can justify all the approach at the same time. But I know that with only this stuff, it seems like crushing a nut with like a sledgehammer or something. So
no, it's not the criticism. It's just that you, from the perspective that you have, and you can tell the one people who are not using category theory, maybe say, okay, you should use it for.
Yeah, but I think you should use it because, well, you can first classify every action logic within this framework, and then you can correlate the properties of the logical connective, and then say, well, if I don't want, for instance, commutativity, then I know where to go in which deductive system. So.
Okay, thank you. That's all I had.
Thank you very much. So, deserved round of applause there. Questions for Clayton? Janelle?
I'm curious. You mentioned you want to, in your future plans, maybe combine this with the deontic logic.
It's done, actually.
Yeah. Curious. It seems to me that those deontic, how do you call them, operators seem to be, they are not actions. A duty, well, you have a duty to do some action or something like that. But having a duty is not an action, so would it be some kind of layer or something?
No, I mean, you can have a deontic formula like it's obligatory that some action, and this is declarative, right?
Yeah.
But the action is not declarative.
Oh. Yeah.
So that's kind of the approach is how to do. So in the scope of the deontic operators, I only have actions which are not declarative sentences.
Oh, yeah.
As opposed to some other approaches which are to be with declarative sentences in the scope of the parameters.
Yeah.
Does that
Okay.
answer your question?
Yeah, that answers my question. My ignorant question. Okay.
Other thoughts, questions? Rick?
Sorry. You seem to be putting STID and dynamic logic in the same
In the same basket.
area, in the same basket, and then say that yours is an alternative approach. But from what I get with this talk, you're really in the area of dynamic logic, and STID is something altogether different. And it could be that you could combine this with some version of STID, like has been done with dynamic logic and STID.
That's an avenue for future research, I think, to see how this kind of thing could be mixed with STIDs and dynamic logic. But for now, I just use this thing with another deductive system for reasoning with conditional and non-conditional negations.
Any other questions?
I think they're hungry.
Yes, I get that sense too, but I wanted to allow everyone to say their piece if they needed to. So let's thank Jessen and Clayton once again.